Assalamu alaikum everyone. How are you guys? Walaikum assalam. Good evening. How are you guys? I'm good too, alhamdulillah. Thank you for asking. Walaikum assalam. Okay, so first of all, make sure that you guys download the notes and the worksheets that I've shared. You will find a link in the description. Walaikum assalam. And then let's start. So here's what we're gonna do. You will find detailed notes in the description. Okay, so we are going to cover the concept, but it's practically not possible to cover everything, all the concepts in one stream. So what I'm going to do is, yes, I will cover it from scratch, inshallah, but we'll have multiple sessions. Okay, so I'm looking at probably 3 streams of maybe hour and a half, 2 hours each, which will allow us to cover all of functions. Okay, so if you want to cover in detail, that means we have to spend a good amount of time. Otherwise, there's no point in doing it. Okay, so I'll do a bit of both. I'll do concepts as well as past papers, but the main concept that I will be covering, that I think I'll be able to cover today, is just types of functions that we have and domain and range, not more than that. So that means there's most likely going to be another stream in which we're going to cover domain and range and types of functions as well. So first things first, let's write down the date and let's talk about what exactly functions are. So today is the 11th of Feb 2025, and every time I write down the date I realize how close CIEs are. Now, what is a function? Who can tell me what a function is quickly? And keep it simple. A function is a, good evening, when will I do mechanics? Mechanics I'll do close to exams, because mechanics is not a lot of syllabus, so I'll do mechanics inshallah close to exams, most likely in function is a heading. That's funny. Close to exams inshallah, okay, so don't worry. And S1, yes, I'll do more of, I know the combinations playlist is very pending, so is pending for a very long time, so I will do that also. So a function is a relation. A function is a relation where every input has only one output. Now, before I move further, I would like to always mention that please subscribe to the channel in case you haven't done so, and I would also appreciate if you like this stream. So a function is a relation where every input has only one output. Now, input has a specific name. We call the input the domain. That's what we like to call it in functions. Okay, and these are basically your x values. Okay, and then there is output. And then as far as output is concerned, output is basically the range. And these are your y values, or because we're talking about functions, we don't write y as y. We write it as f of x. Okay, so guys, I'll do a vote on my Instagram and also on YouTube, so make sure that you give your input, because I did a vote recently and functions had the most votes, so that's why I'm streaming functions. So what's a relation? Relation, by the way, just so you guys know, is any equation. Okay, so any equation where every input has only one output, that is basically a function. So think of it this way, that you have a set which contains all the relations, and then inside of that set is where you have all the functions. Okay, so inside this you have all the relations, that means all the equations that you can possibly think of, and then not every relation is a function as mentioned. That means there are a few of them which happen to be functions as well. Okay, so you can make a note of that, that not every relation, meaning not every equation that you can possibly think of, is a function. Now, a function can be of two types. Okay, a function can be of two types. Who can tell me what are the two types of functions there are? Anyone who can tell me the two types of functions that there are? P5 in 7 days. Oh, I guess you have your exams in Feb. You're giving exams in the Feb-March session. Yes. Okay, I'll definitely try. One-to-one function. Now, what's a one-to-one function? A one-to-one function is basically where one input gives one output. Okay, one input gives one output. Like, for example, a linear function or an exponential function, even a logarithmic function, but let's keep it linear and exponential since that's what we're all familiar with. Then you have a many-to-one function. Okay, so what's a many-to-one function? So AdMath students can also watch this stream, by the way. Okay, a many-to-one function is where you have many input. Okay, where there are multiple inputs that give the same output. Can anyone give me an example? Many values of x that give you the same output. Yes, that is correct. So example would be a quadratic. A quadratic is an example of a many-to-one function, a cubic, and even trigonometric. So these are all examples of many-to-one functions. All right. So let's talk about what is not a function. So what's not a function? One-to-many. So a one-to-many, so some people say that one-to-many function is not a function. So that's incorrect. You're calling it a function and then you're saying it's not a function. That's not how it works. So one-to-many relation is not a function. Okay, so one-to-many kind of a relationship is a relation and it's not a function. Now, anyone who can give me an example of a one-to-many relation? Any example? And by the way, one-to-many basically means that where you have one output, one input that gives multiple outputs. That's correct. Circle. One input gives multiple outputs. Like, for example, a circle. Okay, circle is the only kind, no, not exponential, circle. Why is that? Why is a circle considered a one-to-many relation? Let's say you have x squared plus y squared is equals to 9. So if you make y squared the subject, that's going to be 9 minus x squared. Then if you make y the subject, so that's going to be plus minus square root of 9 minus x squared. So that means if you plug in a value of x, you will get two different y values because of the plus minus. Okay, so this is an example of a one-to-many relation. Okay, remember, one-to-many relation is not a function. Yeah, if you take a quadratic function and you flip it 90 degrees, that is also correct. Okay, that is also an example of something that's not a function. Okay, let's do some examples. So in this stream, inshallah, we're going to cover types of functions and we're going to cover domain and range. So let's say you have f of x, which is equal to 2x plus 3. Okay, and x belongs to the set of real values. Yes, you can do that. You can watch my APGP stream for AS Math. That is very similar to AdMaths. Okay, now what does this mean? We're going to talk about this in detail, but this basically means that you can plug in all real values of x. Okay, that you can plug in all real values of x. Now this is an example of a one-to-one function. So this is something that we call a mapping diagram, okay, where we write down different values of x and we see what are the different y values that we get. So let's plug in 1, let's plug in 2, let's plug in 3. If you plug in 1, what do you get? You get 5. Okay, if you plug in 2, 2 times 2 is 4, 4 plus 3, that's equal to 7. And then if you plug in 3, 3 times 2 is 6, 6 plus 3 is 9. Okay, so these are your x values and these are your f of x values. X, f of x. So this is an example of a one-to-one function. Now let's see what it looks like when we make a rough sketch. Okay, this is a rough sketch only. So here we have a rough sketch of 2x plus 3. Here we go. So this is 3, the y-intercept, and you can see that if you plug in 1, you get a different y value. If you plug in 2, you get a different y value. If you plug in 3, you get a different y value. That's how it works. So this is an example of a one-to-one function. Okay, this is an example of a one-to-one function. So when you plug in 1, you get 5, 7, and 9. Here's your x-axis, and this is your f of x-axis. Now, next is another example. Let's do another example. Let's say you have f of x, which is equal to 2 power x, and x belongs to the set of all real values, meaning that you can plug in all real values. Yes, I'll do past papers as well. You can plug in all values that you can possibly think of, not a problem. Okay, so here, if you plug in 1, you get 2. If you plug in 2, you get 4. If you plug in 3, you get 8. So here you can see this is what the graph looks like. And here also, if I quickly make a mapping diagram, if you plug in, let's copy this only. So if you plug in 1, you get 2. If you plug in 2, you get 4. If you plug in 3, you get 8. Okay, and you can see that from the diagram as well, that if I plug in 1, we get 2. If you plug in 2, you get 4. And similarly, if you plug in 3, we get 8. Okay, so nothing new so far, I hope. Then let's take a look at a quadratic function. Let's say you have f of x, which is equal to x squared minus 6x plus 8. And here, x belongs to the set of all real values as well. Okay, x belongs to the set of all real values. Now, the reason why this is called a many-to-one function is for this reason. So let's say I plug in a specific set of values and notice what the output is going to be. So let's say that I plug in 2, 3, and 4. Okay, I plug in 2, 3, and 4. These are the values of x that I plug in. So if I plug in 2, we get 0. Okay, if you plug in 2, you get 0. If you plug in 3, then you get minus 1. And if you plug in 4, you get 0 as well. Okay, so that is why this is called a many-to-one function. Why is this called a many-to-one function? Because you can see that there are many different values of x that are giving you the same y value. Now let's see what the graph looks like. This is what the graph looks like. So here's an example of a many-to-one function. Okay. Now last, let's look at a one-to-many relation. Let's look at x squared plus y squared equals to 25. Okay, and as we mentioned earlier, that this is a one-to-many relation and not a function. Why is this a one-to-many relation? Because if you plug in 3, for example, if you plug in 3, then you will get 2 different y values. So if you plug in 3 in place of x, let's make y the subject. So y squared is equals to 25 minus x squared, which means y squared is y is equal to square root of 25 minus x squared with a plus minus. So if you plug in 3, so y is equals to plus minus. 3 squared is 9, 25 minus 16. 25 minus 9 is 16, so that means you get y is equals to plus minus 4. So that's the reason why this is called a one-to-many relation. Okay, and let's see what the graph looks like. Here's what the graph looks like. Here we go. This is what the graph looks like. Okay. Now, actually, this is not the last example. Now I'm going to do the last example, and then we're going to talk about, some horizontal line test and vertical line test, which you guys might already be familiar with. All right, let's see if I can. O-level maths. Yeah, I'll do O-level streams as well. Don't worry about it. Sir, how similar is add-math functions to AS functions? Quite similar. At least the concepts are similar. All right, I appreciate that. Sir, अगर इसमें under root x है वो भी one to many होगा ना? Yes, even if let's say you have y is equals to, given that there is a plus minus, only then will it be a one to many. Okay, otherwise it won't. So last example is f of x equals to sine x. And let's say this is from 0 to 360. So what kind of a function is this? This is also a many to one function. No, I will not do transformation of function today. There will be a separate stream for that entirely, because it's a separate chapter altogether. Yes, I know it's in functions, but it's a separate chapter altogether, okay? So this is basically the graph of f of x equals to sine x. And this is a many to one, sorry, not many to one. Yeah, many to one, sorry. Many to one function. Okay. Now, let's understand some tests. Okay, so we have something called graphical tests. Okay, what do we have? We have something called graphical tests. There is something, and remember this can only be used, note this can only be applied, if graph is given. If the graph is not given, that means we cannot use this test. Now, what are these tests? Let's talk about them. So, there is a test called vertical line test. Okay, now what's a vertical line test? Let's see. A vertical line test is basically to distinguish. A vertical line test is to basically distinguish a function from a non-function. Okay, so vertical line test, yeah, I'll post this slide, don't worry. And then you have a horizontal line test. Okay, what do you have? You have a horizontal line test. What's a horizontal line test for? A horizontal line test is to distinguish a one-to-one function from a many-to-one function. That's what it's for. A one-to-one function from a many-to-one function. Then the condition is, the question is, what's the pass and fail condition? It's a test, right? So a test could be a pass or a fail. So pass is when it cuts only at one point. Okay, so if a line cuts only at one point, that means it passes the test. Then what's the condition to fail? The condition to fail is that it cuts more than 1 point. Okay, it cuts more than 1 point. So let's apply these tests. Okay, let's apply the vertical line test over here. So if I apply the vertical line test here, that means I can literally draw a vertical line anywhere I want. Okay, so think of it this way. Imagine that you have a vertical line here, and imagine that you slide it around. Okay, so as I slide this vertical line around, doesn't matter where I draw it, it will always cut it at 1 point. Okay, it will always cut it at 1 point. Therefore, it's a one-to-one function. Because the vertical line test is cutting it at 1 point, that means it's a one-to-one function. Okay, I repeat, because the vertical line test will always cut it at 1 point, that means it's a one-to-one function. Then let's talk about the horizontal line test. So because imagine that you draw a horizontal line and then you slide it around. So it doesn't matter where you draw the horizontal line, it will always cut it at 1 point. So if the horizontal line is cutting it at 1 point, that means this is not only a function, it is also a one-to-one function. Okay, so earlier we figured that it's a function. Now we have also figured that it's a one-to-one function. Okay. Now here also, if you think about it, doesn't matter where I draw the vertical line, it will always cut it once, which is why it's a function. And also, it doesn't matter where I draw a horizontal line, it will always cut it once, which means not only it's a function, but it is a one-to-one function. Okay? Now, what about here? Here, if you draw a vertical line, okay, so if you draw a vertical line here, so no matter where you draw it, it will always cut it once. Okay, so it doesn't matter where you draw the vertical line, it will always cut it once. But, which by the way means that it's a function, But here's the thing. If you draw a horizontal line, okay, if you draw a horizontal line, then it cuts it twice. Okay, so the horizontal line cuts it twice. That means it's a many-to-one function. It's a many-to-one function. Because the horizontal line cuts it twice, that means it's a many-to-one function. As far as a circle is concerned, when we draw a vertical line, it cuts it twice, so that means there is no point in testing whether it's a one-to-one function or a many-to-one function. It's not a function to begin with. As far as a trigonometric curve is concerned, trigonometric curve like this, if I draw a vertical line, it will always cut it once. But if I draw a horizontal line, it will cut it twice. That means this is an example of a many-to-one function. Now there's another way to identify a one-to-one function from a many-to-one function. Okay, there is another way to identify a one-to-one function from a many-to-one function. What's that? Let's see. So if you think about this, if you look at this curve, you'll notice that this is always increasing. Okay, what's there to observe? A one-to-one function is either always increasing or always decreasing. So this is always increasing. If this was a downward sloping line, it would always be decreasing. Okay, therefore it's a one-to-one function. We'll write this down as well. If you look at this, this is also always increasing. If let's say this was drawn the other way, then it would always be decreasing. It would still be a one-to-one function, but it would always be decreasing. However, if you have a many-to-one function is a function where it's always decreasing, where it's doing both, by the way. It's decreasing as well as increasing. Okay, so that's another way that you can distinguish a one-to-one function from a many-to-one function, and we'll write this down as well. Don't worry. Here also, actually no, this is not a function to begin with. Here also, reason why it's a many-to-one function is because it's doing both. It's increasing as well as decreasing. Okay? Now, some important notes. This chapter is full of important notes, so make sure that you don't take them lightly. Here are some important notes. A one-to-one function is either always increasing or decreasing, but not both. Okay, a one-to-one function is either always increasing or always decreasing, but not both. That means it could be an upward sloping line, it could be a downward sloping line, it could be a curve like this, an exponential curve, okay, which is going in this direction, or it could be something like this. So this is what a one-to-one function looks like. Many-to-one function, on the other hand, a many-to-one function will be both, meaning that it will be increasing and decreasing under a given domain. Okay, so if you have a many-to-one function, it will be both increasing as well as decreasing under a given domain. But yes, what you can do is you can always make an increasing function, you can make a many-to-one function a one-to-one function as well. Okay, so we'll talk about that also. So here, for example, so this is an example of a many-to-one function, and this also is an example of a many-to-one function. Now, once again, some important notes. Okay, some important note. And that is how to turn a quadratic function, which is by default a many-to-one function, to a one-to-one function. Let's have a look. Let's see how we can turn a quadratic function, which by default is a many-to-one function, to a one-to-one function. So this is what a quadratic curve looks like. Okay, I'm sure we all are familiar with what a quadratic curve looks like. This is what it looks like. So you can see by default, it's a many-to-one function. Why? Because it's decreasing as well as increasing. So if I ask you guys that give me a domain, suggest a domain according to which this becomes a one-to-one function. Can you do that? Can you suggest an appropriate domain under which this becomes a one-to-one function? Let's see if you guys can do that. And this, by the way, h is the x coordinate of the turning point. So when the domain is such that x belongs to the set of all real values, by default, this is a many-to-one function. Why? Because it is decreasing as well as increasing. And also because the horizontal line cuts it twice. However, if I change the domain slightly, meaning if I make it x is greater than h, or even if I make it x is greater than or equal to h, then what happens? It becomes a one-to-one function. Why? Because then you're only looking at this part of the curve. If we change the domain to x is greater than h or greater than or equal to h, this becomes a one-to-one function. Or even if, let's say, x is lesser than or equal to h or x is less than h, then also this becomes a one-to-one function. Why is that? Let's have a look. Yeah, TP is short for turning point. That's correct. So if it is greater than h, that means this is the kind of curve that you will get. And here, no matter where you draw a horizontal line, it will always cut it once. If it is less than h, that means this is the kind of curve that you will get. And here also, it doesn't matter where you draw a horizontal line, it will always cut it once. Okay? Now, let's talk about domain and range, and then we'll do some past paper questions. So that was just an introduction to functions. Now we're going to talk about domain and range in detail, and I guess that's the pain point for a lot of students. So first of all, domain समझ लेते हैं कि होता क्या है. Okay, let's understand what domain is. So every time you come across something like this, 5 upon x minus 3, you will often notice that you're given x is not equal to 3. Now, why is it that you're given x is not equal to 3? Why? Because if you plug in 3, then the whole function becomes undefined. So by default, what is domain? Domain are basically all the values that can be plugged into the function. Okay, that's your domain. All the values that you can plug into the function, that's your domain. What's the range? Range is all the output values. Okay, all the output values, meaning all y values. Okay. Now, there are some functions which naturally have a domain, as in naturally there is some value of x that you cannot plug in. Like, for example, if you have f of x is equal to root x. Now, we know that in order to keep this function alive, value of x must be greater than or equal to 0. Let's say you have f of x, which is equal to 1 upon x. That means इस function को जिंदा रखने के लिए x must not be equal to 0. Okay, so these are basically the idea behind domain. The idea behind domain is to plug in a value which keeps the function alive. Now then there is some restricted domain as well. Okay, so let's do some examples. Let's do some basic examples, and then we'll do some past paper questions as well. So let's say the question says that find the range of f of x, which is equal to 3x minus 1 for the following domains. Okay, and what's the domain? Here it is. Let's say you have x, which belongs to the set of real values, and then there is a restricted domain, which is minus 2 to 3. Okay, so when x belongs to the set of real values, that means there is no restriction. So there is no upper limit, there is no lower limit. That means you can plug in a value as great as possible, you can plug in a value as small as possible, nothing to worry about. And because the greater the value that you plug in, the greater the y value, the smaller the value that you plug in of x, the smaller the y value. So that means the range is going to be f of x belongs to the set of all real values. Okay? But if there is a restriction, if let's say you're restricted and you can only plug in values from minus 2 to 3, then that means you're only looking at a specific part of the curve. You're only looking at the output value that you get after plugging in 3, which is 8, by the way, and the output value that you get by plugging in minus 2, which is minus 7. Okay, so that means if I'm only looking at this part of the graph, let me highlight it. If I'm only looking at this part of the graph, then that means the range for this part is going to be as follows. F of x is greater than or equal to minus 7 and lesser than or equal to 8. Okay. What is the schedule of live streams for AS? I usually announce on my Instagram. Okay, I usually announce on my Instagram. Yes, this video is also suitable for add math functions. Okay, initially it's all the same. Now let's do another example. Let's say we have the following question. Okay, I'll just copy paste the question to save some time. Let's say this is the question. So you have to find the range for f of x equals to 2 power x, and this is the domain that you're given. Now let's make a rough sketch. Okay, so here it is. This is what a sketch looks like of 2 power x. Now here you can see that there is a natural limit to it. Okay, you can see that there is a natural limit, as in the graph of 2 power x, the least it can be is 0, and it's never equal to 0. Okay, it's always, if you zoom in, you'll notice that it's never equal to 0. It's always above 0. It's always greater than 0. So that means if there is no restriction, then the least value that we can get is always going to be greater than 0. And as far as the greatest value is concerned, there is no limit to it, because this will go on forever. So therefore, f of x, which is the range, is going to be greater than 0. Okay, the range is going to be greater than 0. But if we restrict ourselves from minus 2 to 3, that means if you plug in minus 2 in this function, you will get 1 upon 4. Okay, you can do that. 2 power minus 2 is 1 upon 2 squared, and you will get 1 upon 4. And if you plug in 3, which is right here, you will get 8. 2 power 3 is 8. So that means if we restrict ourselves and we are only allowed to look at this part of the curve, then what will we observe? We will observe the graph to be from 1 upon 4 to 8. Okay, so that means for this part, f of x is greater than or equal to 1 upon 4, lesser than or equal to 8. Okay, pretty easy so far, I'm sure, but things will get complicated. No, you don't need to sketch. I'll tell you when you have to sketch. Okay, I'll tell you when you have to sketch. Now, let's do another example. Here's example number 3. Okay, and once again, let me copy paste to save some time. Here. Find the range of f of x, which is equal to x minus 2 the whole thing square plus 3 for the following domain. So let's make a rough sketch, and I'll tell you when you have to make a rough sketch and when you don't. Okay, let's make a rough sketch and see what do we get. So this is what we're looking at. We're looking at something like this. So here's the y-axis. Here is the x-axis. Okay, this is the curve. The turning point, by the way, is going to be 2, 3. That means there are no x-intercepts. So we're looking at something like this. Okay, now here is the x-coordinate of the turning point, which is 2. And here's the y-coordinate of the turning point, which is 3. Okay, and by the way, I hope you guys know how to find out the turning point from completed square form. Now, if let's say x belongs to the set of all real values. Now, can I say that if x belongs to the set of all real values, meaning that there is no restriction on the x value that can be plugged in, can I say the following, that f of x belongs to the set of all real values? Can I say that like we did for a straight line? No, we cannot. Why? Because we can see that there is a limit. Okay, there is a minimum y value which the function is always equal to or greater than. So therefore, the correct answer would be, because it's a minimum curve, the correct answer would be f of x is greater than or equal to 3. That would be the correct answer. F of x is always greater than or equal to 3. This is the correct answer. Now, if let's say the domain is from -2 to 3. Okay, if the domain is from -2 to 3. So if the domain is from -2 to 3, let's see if we can do the following. How about I plug in -2, I plug in 3, and then I give the answer in range form. Let's see if we can do that. So let's plug in -2. If you plug in -2, you will get 19. And then if you plug in 3, you will get 4. Okay, so tell me if this makes sense. So let's extend this a little. We might need it. Let's erase this. So if we plug in -2, which I believe is somewhere over here, okay, so somewhere over here is -2. So the corresponding y value of -2 gives us, the corresponding y value of -2 is 19. So that means that this corresponding value is equal to 19. And then if I plug in 3, which is approximately somewhere over here, what do we get? We get 4. So that means when you plug in 3, you get 4. So that's approximately somewhere over here. I know it's getting a little messy, but I hope you guys are following. So can I say the range is from 19 to 3? Can I say that? Can I say that the range is from 19 to 4? Sorry, can I say that? Let's see. Can I say that f of x is greater than or equal to 4, lesser than or equal to 19? Can I say that? No, we cannot. Why can we not? Why can we not say that? Because if you look at the graph, you will notice that 4 is not the minimum value. Okay, in between, somewhere, it's further less than 4, and that's equal to 3. So that means this is not correct. The correct answer would be f of x, let's write down the correct answer now. F of x is greater than or equal to 3, lesser than or equal to 19. Okay, and if you're wondering how will we know how to give the correct answer and how not to give the correct answer, we'll find that out. Now here's the thing. If we apply that approach over here where we plug in 3 and we get 4, and if we plug in 5, we get, let's see what we get if I plug in 5. So when you plug in 5, you get 12. If I apply that approach over here, then we get away with it. Here's 4, here's 12. If I apply that exact same approach over here, then we get away with it. So how come we get away with it over here and we don't anywhere else? How come? How is that? That is because if you're only looking at this part of the curve from 3 to 5, then it kind of becomes a one-to-one function. Okay, it kind of becomes a one-to-one function. So here are some important notes that I'm going to walk you guys through, and then we're going to do some past paper questions. Here. So in order to find out the range of a one-to-one function, okay, like for example, this one or the one before, what do? We can simply plug in the two endpoints of the domain and give answer in range form. So like for example, here we plugged in this point and give the answer in range form. Here also we plugged in this point and we gave the answer in range form. But in order to find out the range of a many-to-one function, we have to make a sketch and find the minimum / maximum value before stating the range. Okay. Another important note, which I will add here, that if the x coordinate of the turning point is inside the domain, okay, if the x coordinate of the turning point is inside the domain, then the function is a many-to-one function. Okay, I'll repeat. If the x coordinate of the turning point is inside the domain, then it's a many-to-one function. If the x coordinate of the turning point is outside the domain, that means it's a one-to-one function. Okay, I'll explain this again. See here, we don't have to worry about the function decreasing and increasing all of a sudden. Okay, it's only going to do once. It's only going to do one thing. Either it's going to increase or it's going to decrease. Here also, if it's increasing, it's constantly going to increase. It's not going to decrease. But when it comes to a quadratic curve, it may be decreasing and then it will be increasing. Okay, when it comes to any many-to-one function, it's decreasing as well as increasing. So if we plug in the endpoints of the domain, and given that the x coordinate of the turning point is somewhere in between the domain, that means we may not get the correct answer. So just like here, if we plug in, let's say -2, which gives us 19, and if we plug in 3, which gives us 4, then 19 to 4 is not the correct range. Why? Because somewhere in between the graph, somewhere in between these two values of x, the graph reaches a minimum value of 3. But if you do that over here, if you plug in 3 and 5, okay, if you plug in 3 and 5, then you get the correct answer. Why? Because as per this domain, okay, as per this domain, the function is a one-to-one function. If we just look at this domain, it's a one-to-one function. And if we look at this domain, then as per this domain, this is a many-to-one function. Okay, so let's do some past paper questions and see what's what. Okay, so past paper question is where we will do most of our learning. So the past paper questions that I will be doing are from the worksheets, which I've already uploaded. Make sure to download them. And I'll take out the worksheets quickly, just a minute. You guys can download the worksheets from the link in description. Just a minute. Today we're just going to be solving worksheet 1, inshallah. Just a second. Here. So here's a very simple question. It's a past paper question where we have to find out the range. Let's see how we can solve this. So this says a function f is defined by f of x equals to 2x squared minus 16x plus 23. Express f of x in this form, and don't forget to look at the domain. The domain is x is less than 3. Okay? And we have to first express it in completed square form. So you'll notice that the question might ask you to maybe draw the range draw the curve first, or maybe the question might ask you to express it in completed square form, maybe even a combination of both. So let's see how we can express it in completed square form. I'm going to use the method that we learned in math. So we start by taking 2 common. First, let's write down the equation. So that's 2x squared minus 16x plus 23. Let's take 2 common. Let's see what we get if I take 2 common. So if I take 2 common, what we get is this. 2x squared minus 8x. Okay, leave a bit of space, close the bracket, and then write plus 23. Okay. Now, which I'm using GoodNotes. Okay. So what is it that we're going to add in order to turn it into a complete, what is it that we're going to add to bring it in completed square form? We're going to add 4 squared, and we're also going to subtract 4 squared. So this part of the expression becomes x minus 4 the whole thing square. This is minus 16. Don't forget that you have a 2 outside, and then a plus 23. Okay, so let's see what this becomes. This becomes 2x minus 4, the whole thing square, minus 32 plus 23. So what's minus 32 plus 23? Let's work it out. Minus 32 plus 23, which is equal to minus 9. So 2 is equals to, this is equals to 2x minus 4, the whole thing square, minus 9. Now, can we find out the range directly? No, I don't recommend it. I don't recommend that you find out the range directly. Okay, so your safest bet is to make a rough sketch. So if you want to find out the range, I would strongly suggest that you make a rough sketch. Why? Because this is a many-to-one function. And you don't have to be very precise when making a rough sketch. Just get the turning point right and you're good to go. So these are the coordinates of the turning point. This is what we're looking at, 4, minus 9. That means here's 4 and here is minus 9. Now notice the question says that x is less than 3. So that means you're only allowed to look at a certain part of the curve. Let's see what happens if we plug in 3. If I plug in 3 in this function, let's see what do we get. So if you plug in 3, that's going to be 2 into 3 minus 4, the whole thing square, minus 9. So we get minus 7. Now, if you're only allowed to look at this part of the curve, okay, if you're only allowed to look at this part of the curve, then what would you say the range is? Notice the least value is minus 7. Okay, here's the least value, which is minus 7. This is the least value. And all the other values are greater than minus 7. So that means the range is f of x is greater than minus 7. Not even greater than or equal to, because 3 is not included. So as per this domain, it's greater than minus 7. Okay, I repeat. When you plug in 3, what do you get? You get minus 7. And all the other values, this is the part of the curve that you're looking at. All the other values are greater than minus 7. So that means the range will be f of x is greater than minus 7. Okay, let's do another question. Let's do another question from the worksheet. And here it is. Express minus 3x square in the form minus 3 into x minus a, the whole thing square plus b, where a and b are constants. The one-to-one function f is defined by so-and-so, where x is lesser than or equal to k. Okay, so first part, we have to bring it in completed square form. That's how you will notice if you have a quadratic function related question, that means the first part, you're very likely to bring it in completed square form. So let's start by taking minus 3 common. So we have x square minus 4x, leave a lot of space, close the bracket, then write plus 2. So what are we going to add to complete the square? We're going to add 2 square. What are we going to subtract? We're going to subtract 2 square. So this part of the expression becomes x minus 2 the whole thing square. This minus 4 remains as is. Minus 3 outside, and don't forget the plus 2. So we have minus 3 into x minus 2 the whole thing square plus 12 plus 2. So that means minus 3 into x minus 2 the whole thing square plus 14. That's the answer. This is how the question wanted, and we have done just that. Now let's see what the following part says. The following part says that the one-to-one function, okay, now by default, this is not a one-to-one function. Okay, a quadratic function by default is not a one-to-one function, it's a many-to-one function. So although you're not supposed to make a sketch here, and you don't really have to, but let's do it anyway to understand how things work. So what are the coordinates of the turning point going to be? They're going to be 2, 14. So that means this is what you're looking at. Now the question says, state the largest possible value of k, and what does k does? K makes it a one-to-one function. So what should be x lesser than or equal to for it to be a one-to-one function? Let's see. Up until 2, it's increasing. And after 2, what happens? It starts to decrease. So that means if I get rid of this part of the curve, then this becomes a one-to-one function. So for as long as x is lesser than or equal to 2, this will be a one-to-one function. So the answer to part B is x is lesser than or equal to 2, which means the largest possible value of k is 2. Okay, what happens if I take any value of x which is greater than 2? Then the function starts to decrease. That means it has done both increase and decrease. Therefore, it is a function, but it's not a one-to-one function. Okay, so that's the standard way of solving That's the standard way of solving questions like these. The answer is always the x coordinate of the turning point, but make sure that you understand the concept as well. Okay, now let's do a slightly tricky question. Here it is. Let's see what this says. The function f is defined by f of x equals to 2x upon 3x minus 1 for x is greater than 1 upon 3. Okay, what do we have to do? Let's see. We have to, sir, 6 square, why would it be 6 square? Why would it be 6 square? I've taken 3 common, so why would it be 6 square? Let me see. Yeah, everything's correct. Everything is correct. पहले हम square करेंगे, by the way, फिर हम multiply करेंगे. Okay, so we follow rules of BODMAS. We square it first and then we multiply. Which more topics? I'll probably do trigonometry. I'll probably do differentiation integration. So basically calculus. Okay. Now, here's a question. Now, questions like these are not the kind of questions where you can simply make a sketch and answer. Here, you have to go the extra mile. And what do I mean by that? I'll explain. The function f is defined by f of x equals to 2x upon 3x minus 1. And notice we're given x is greater than 1 upon 3. Okay, the question says, part B is a simply math-related question. Show that 2 upon 3 plus 2 over 3 into 3x minus 1 can be expressed as. So what we're going to do is we're going to take the LCM. Okay, let's take the LCM. So if I take the LCM would be 3 into 3x minus 1. Okay, so we're going to multiply this by 3x minus 1. Let's do that. So this will become 6x minus 2. And this will multiply by 3. So this will become plus 6. So that means as far as the numerator is concerned, we are looking at 6x plus 4 over 3 into 3x minus 1. Okay, now let's see if there's anything that we can take common. No, wait a minute. I think I've done something wrong. Wait, I think 2 into 3x minus 1. Sorry, we don't have to multiply this by anything. We'll just multiply this by 1. Sorry, my bad. Yeah, we'll just multiply this by 1. So this becomes plus 2. And this is where we're at. Minus 2 plus 2 cancels. So it's going to be 6x over 3 into 3x minus 1. And then we can simplify. 2 3s are, 3 1s are. And we are left with, 3 2s are, and 3 1s are. And we are left with 2x over 3x minus 1. Okay. Yeah, you're right. Now what we're going to do is we are going to do part C, which says state the range of f. Now how do I find out the range of f? The range of f will be 2 upon 3 plus 2 upon 3 into 3x minus 1. Now notice that the question has made us express it into this form for very good reason. Okay, the question has made us express it in this form for very good reason because this will allow us to find out the range. Okay, how will I find out the range using this? Let's see. Like I said, it's very important that you get familiar with the function. Okay, it's very important that you get familiar with the function. So we're going to do a bit of trial and error. Let's see what happens if I do plug in 1 upon 3. I know we're not supposed to, but let's see what happens if I do plug in 1 upon 3. So that means I will get 2 upon 3 plus 2 upon 3 times 0. Because if you plug in 1 upon 3 and multiply in place of 3x minus 1, you get 0. So that means what you get as a result is 2 upon 3 plus infinity, which is going to be a very large value. Okay, this will be infinity and you will get a very large value. All right, and let's see what happens if I plug in 2. So you have to get familiar with the function, otherwise you're not going to be able to solve questions like these. So if you plug in 2, which by the way is just a random value, which this is going to be 2 upon 3 into 3 times 2 is 6, so 6 minus 1. So let's just find out the final value. So 2 upon 3 plus 2 upon 3 into 3 times 2 3 into 3 times 2 minus 1. So we get 4 upon 5. And what happens as the values keep on increasing? Let's say I plug in 100. So wherever you've plugged in 2, just plug in 100. If you plug in 100, you will notice that you will get a value which is 0.668. And as the values increase, there will come a point where you reach a really large value. Okay, and you have to do this to understand the idea of domain and range. There is no formula which you can use to find out the final answer. If you plug in infinity, meaning that you plug in a really large value, so what will happen is the denominator of this fraction will become infinity. And what is anything divided by infinity? Anything divided by infinity is 0. That means your final answer, your end result, will simply be 2 upon 3. Okay, so think of it this way, that you have a value 2, which you're dividing it by a very large value. So what you will end up with is simply infinity. So you will end up with an extremely large value. And in the end, you'll end up with 2 upon infinity, which is 0. And in the end, you'll just have 2 upon 3. So that means this is the least value. This is the smallest it can be. And this is the greatest value. So the final answer is f of x is greater than 2 upon 3. Not greater than equal to, just greater than 2 upon 3. Why? Because even though this approaches 0, but it will not actually be equal to 0. So the answer is always going to be greater than 2 upon 3. How is 2 upon infinity 0? So think of it this way, that you have 2 slices of pizza and you have 1 million people eating it. Or let's say 1 billion people eating it. So what will be the share per person? Think about it. You have 2 slices of pizza and you have 1 billion people eating from those 2 slices. What do you think will be the share per person? कितना आएगा हर किसी के हिस्से में? Yeah? What do you think will be the share per person? As good as nothing, right? It'll be almost negligible. So why? Because you've taken a very small value. Okay, you've taken a very small value and you've divided by a very large value. So if you take a very small value and divide by a very large value, you get nothing, almost 0. Okay. Now here's another question. Let's see what this is. Function f and g are defined by f of x, which is equal to 3 upon 2x plus 1 for x is greater than 0, and g of x, which is equal to 1 upon x plus 2 for x is greater than 0. Okay, let's see what happens. Find the range of f and the range of g. So let's talk about f of x, which is 3 over 2x plus 1. And here, remember, x is supposed to be greater than 0. Now, like I said, it's very important that you get familiar with the function. How will you get familiar? By plugging in a few values. So if you plug in 0, let's see what you get. Okay, just do it directly in your calculator. 3 upon 2 times 0 plus 1, so you get 3. Okay. Then let's identify a trend. If you plug in 1 in place of 0, let's see what you get. You get 1. If you plug in 10, let's see what you get. You will get 0.143. Then if you plug in 100, let's see what you get. Remember, we are here to identify a trend. You will get 0.01492. And if, let's say, you plug in a really large value, which is infinity, that means you will reach a point where you have 3 upon infinity. And what's 3 upon infinity? This is something that's going to approach 0. So that means this is the largest value, and every other value is going to be less than 3. Okay, every other value is going to be less than 3, and the smallest it can be is 0. Okay, the smallest it can be is 0, and not actually equal to 0, but approaching 0. Just like it can't be equal to 3, it's always going to be lesser than 3. So just like that, it can't be equal to 0. It's always going to be greater than 0. So the answer would be greater than 0 and less than 3. Okay, this is the best way to solve domain and range questions. A lot of people look for an easy way out, and I wish there was one. If there was, I would have been the first one. Not actually, no, I would have given it to you guys straight away, but sadly there isn't. Now let's talk about g of x, which is equal to 2 plus 1 upon x. Here also, let's start by plugging in 0. which I know we can't, but if you do it, you get infinity. Okay, now let's plug in 1. So you get 2 plus 1 upon 1, which is equal to 3. Okay, what are we doing? We're trying to identify a trend. Let's plug in 10, which is going to be 2 plus 1 upon 10, which is equal to 2.1. Let's plug in 100, which is equal to 2 plus 1 upon 100, which is equal to 2.01. Then if I plug in infinity, which means 2 plus 1 upon infinity, 1 upon infinity is a value which is going to be as good as 0. And when you add 2 to it, you're going to get 2. So that means this is the range between which the values lie. The values are, this is the smallest value. And as far as the largest value is concerned, there is no limit to it. Okay, as far as the largest value is concerned, there is no limit to it. So that means f of x will always be greater than 2. Okay, that's the answer. Now let's do some more questions. Let's do one more question actually. Okay, so I've taken out a tricky past paper question. Just a minute, I hope I can find it. Yeah, here it is. Okay, so let's try and solve this question. The function f is defined as follows. So you're given the function f, okay? Keep an eye out for the domain, it's greater than 2. Show that 1 minus 8 upon x squared plus 4 can be expressed as what you're given. So we start by taking the LCM, which is going to be x squared plus 4. We multiply this by x squared plus 4. So we have x squared plus 4. We multiply this by 1. We multiply 8 by 1. So we have x squared minus 4 over x squared plus 4. Okay, and that's it. You probably get 1 mark for this. The remaining 3 marks are to find out the range. And you'll notice in questions like these, you're given a lot of space to work this out. That means the examiner is expecting you to do trial and error. And the reason behind that is because there is no way to do this without any trial and error. So let's plug in 2. Now I know we're not supposed to plug in 2, but let's plug in 2 to understand the trend. So 2 square minus 4 over 2 square plus 4. Let's see what we get. So in fact, let's not plug in 2 in this. Let's plug in 2 in this. 1 minus 8 in this form. 2 square plus 4. So 2 square plus 4 is 8. 8 upon 8 is 1. So that means we get 1. Now let's plug in 20. And this I'm going to do directly in the calculator. 1 upon 1 minus 8 upon 20 squared plus 4. So we get 0.98. Let's plug in 50. Okay, remember, what are we doing? We're trying to identify a trend over here. If you plug in 50, you get 0.9968. Then let's plug in infinity, okay, just to understand the trend. So this is going to be 1 upon 8 over infinity. Achha, by the way, I just realized that if you plug in 2, you actually get 0. Not 1, you actually get 0. Now, if I plug in infinity, this is what happens. What's 8 upon infinity going to be equal to? That's going to be equal to 0. Okay, and then 1 minus 0, that's going to be equal to 1. So that means the answer will always be in between 0 and 1. Okay, the answer will always be 0 and 1. Yes, that's correct. I've just realized that was an error. So f of x is greater than 0 and less than 1. That's the answer. Okay, so this is how you guys are supposed to approach domain and range questions. Now what we're going to do is we're going to keep it till here only. And in the next class, inshallah. Yeah, this is, by the way, this part is not for AdMaths. AdMath questions are pretty straightforward. And in the next class, inshallah, we'll cover the concept of composite functions and domain and range of composite functions. Okay? Composite functions. So this will probably take 2 more streams. Okay, so for now, this is enough. Let's stop here. You guys can download the worksheet, by the way. Make sure that you do download the worksheet from the link in description. And we will do more questions, inshallah, in the next stream. Okay, so I'll stop here. See you guys, inshallah, in the next class. I'll do a vote where you guys can give me your input as to what topic you want me to stream next. Okay, so take care.